Let's finish your retest review. Number 7, notice there's a subtraction sign in between two square root expressions. So let's start by simplifying the square roots if possible, and then we'll combine like terms. So our first square root expression is the square root of 324. 324 is actually a perfect square, and I'll prove it to you. If you type in second, x squared, 324, you get a whole number 18. So this part simplifies to 18, not square root of 18, just 18. There's no square root sign left. Then we can't forget about this minus 3 that's going to get multiplied times the square root of 225. Well, 225 is also another perfect square. Its square root is 15. So we're just taking 18 minus 3 times 15. So this can be typed into your calculator like this, just like we've written it on our paper. Or I want to show you when it actually ends up being perfect squares like this. You could have actually typed in the original problem from the get-go as it appears, and you would get the same thing, negative 27. It doesn't always work that way, but it's worth it to check. Number 8, we don't want to forget about the expression that's on the outside, but let's worry about simplifying the inside first. 98 is not a perfect square, so I'm going to draw my factor ladder. Hiding in 98 is a pair of 7s. So I'm going to have a 7 come out. I'm going to leave a little space for my variables, and then a 2 stays inside. But while I'm thinking about it, I'm going to make sure that I don't forget to multiply whatever I get on the outside by 5x cubed y squared. All I did was drop that down. Okay, then I've got x squared, which can be expanded as x times x. Notice there's one pair and no leftovers. Then I've got y to the 9th. And going through, we can see that there are 2, 3, 4 pairs. So a y to the 4th comes outside, and there's one y left over on the inside. Just a reminder of the rules: when you have variables with even exponents, you simply divide by 2 to take the square root. This 2 here divided by 2 gives us a 1, and we don't need to write the 1 exponent. Then we have y to the 9th, which has a odd exponent, so the one odd y stays inside. Taking away that one y leaves us with 8, and then 8 divided by 2 is 4. Let's clean up the outside part. I have a 5 times a 7, which gives me 35. X cubed times x to the 1st gives us x to the 4th. And y squared times y to the 4th is y to the 6th. In number 9, we're subtracting and adding. Whether we're adding or subtracting radicals, we have to simplify the radicals or square roots first, and then combine like terms. The square root of 2 cannot be simplified, so I'm just going to drop this down and deal with it later. But the square root of 72 can be simplified. It's not a perfect square, so I'll need to do my factor ladder. And we have two pairs, a pair of 2's and a pair of 3's, and we can't forget about the negative 6 that's in front. So we already have a negative 6 outside, and then that pair of 2's comes out as 1, 2, the pair of 3's comes out as 1, 3, and we're left with a 2 on the inside. In the last square root expression, we have a +8 that's on the outside. Don't want to forget about him. And 50 is not a perfect square, but it can be simplified. Notice we have a pair of 5s. So that pair of 5s comes out as 1 5, and we're left with a 2 on the inside. So the first part stays the same, just 4 square roots of 2. But then we have a -6 times 2, which is -12, times 3, which is -36. And then the last piece, the 8 times 5 on the outside is 40. And notice now that all 3 terms have a square root of 2 attached to them. So we can combine them together. We have a +4, a -36, and a +40. That combines to make 8. So our final answer is 8 square root of 2. Number 10, same type of problem. Let's try to simplify the square root first. Okay, so we can see there's a pair of 3s, but there's already a 3 outside, so let's bring him down. And then the pair of 3s comes out as 1 3, and a 5 is left over. Now, square root of 36 can be simplified, but it's actually a perfect square. The square root of 36 is just 6. So this last part is just going to be a +7 times the square root of 36, which is just 6. So let's simplify. The first piece, 3 times 3, gives us 9 square root of 5. And the second piece, 7 times 6, is 42. Notice that the 9 has a square root of 5 attached to it, but the 42 does not. So we cannot combine these. They are not like terms. So we have to keep them separate, and we've got our final answer. Number 11, let's start by simplifying each square root. Okay, on the first part, I have a 5 on the outside times the 2 that comes out as well, and a 3 that's left over. Now 48 can be simplified. It's 2 times 24, which is 2 times 12. And it just keeps going with a bunch of 2s, and then finally a 3, which is where I stop. So I've got 2 pairs of 2s and a leftover 3. But notice that this second piece is being subtracted. So I'm going to have a subtraction sign, and then 2 times 2, and a leftover 3. So the first part simplifies to 10 square root of 3. 2 times 2 is 4, and it's a minus or -4 square root of 3. Notice both terms have a square root of 3 attached to them, so I can combine like terms. 10 plus a -4 is a +6. All right, we've got finally the square root of 200. Not a perfect square, but it definitely simplifies. Notice there's 2 pairs, a pair of 2s and a pair of 5s, and there was nothing out front or outside of the square root sign. So I'm simply going to have a 2 and a 5 that comes out, and a 2 that's left over. The 2 times 5 on the outside simplifies to 10, and I'm left with the 2 on the inside. Okay, the last 2 questions on your retest review are solving equations. This is a skill that's going to be really important for you as you move forward in math, and we want you to keep that skill fresh in your mind. So let's practice solving a couple equations. It always helps to start by drawing a line down the equal sign. Notice in number 13 there's no parentheses, so I don't have to distribute. On the left, there's no like terms, and on the right, there aren't any like terms either. So I'm going to take a look. I've got a x on both sides of the equal sign. So I need to do the opposite of the one with the smaller coefficient. That means I'm going to subtract 2x on both sides. So on the left, 5x minus 2x is 3x. The plus 2 drops down, and 2x minus 2x cancels out. Notice that the 7 has a subtraction sign with it, so you need to bring that down as a negative 7. Okay, next we'll move on to boxing our variable and doing the opposite of what's not in the box. So that leaves us with 3x equals negative 9. The last step to get x by itself is to divide by 3. So we can see that x equals negative 3. Number 14. Again, we're asked to solve for x, so let's start by drawing our line down the equal sign. Notice this one does have parentheses, so I'm going to distribute the number in front. 3 times x is 3x. 3 times negative 1 is a negative 3. From there, we're just going to box the term with our variable and do the opposite of what's not in the box. That leaves us with 3x equals 21. The last step is to divide both sides by 3, and that leaves us with our answer. X equals a positive 7. This concludes your retest review. Now go schedule your retest with your teacher.